so in the last piece we looked at chi-square tests for independence, and we calculated that through effectively by hand. And by doing that, we looked at expected values, we looked at the observed values, we looked at the chi-square calculation, we looked at calculating the degrees of freedom, and we looked at finding the critical values. Okay, looking what that critical value is, and then whether or not to accept or reject the null hypothesis. In this section, I'm going to show you how to do that more quickly on a calculator. So the first thing I'm going to do is we found the critical value of 3.84, okay, using a table of values. This time, I'm going to show you how to do that on a calculator. So if you were to press menu, the menu button on your calculator, and you'll see the same thing happening on this board. So I click the menu button on my calculator. Oops. I'm actually going to go to my calculator and then click the menu button on my calculator, and we can see the different list here on our menu. And we're going to go to probability because we're looking at the probability. The probability of something happening, and we're looking at 0.05. So we press 5 on our calculator, and when we press 5, we get 5 options on our calculator. This is looking at distribution. If you know from your mathematics classes, I know a lot of you have been doing distribution curves recently. We're going to be looking at distribution. So we click on 5 again, and once we click on 5, we have a whole list of items there. The next place we want to go is for this inverse chi-squared. So we're going to press inverse chi-squared, which is number 9. That's going to give us some information, okay? And in that information, it's asking us for the area. So what area of our distribution curve we're going to look at. Because we're looking at 0.05, we're looking at the area other than that, so we're going to look at 0.95 to make 100%. So we'll type in 0.95. If you're looking at 0.01, if you're looking at 1%, you type in 0.99. Okay. If you were looking at 10%, you type in 0.90. So we're going to type in 0.95, 0.95 into the area, and then we're going to look at our degrees of freedom. Now remember, we worked out our degrees of freedom over here. Okay. And we knew that we had 2 rows -1, 2 columns -1, multiplied them together, and we got 1. So we're going to write in our degrees of freedom of 1. And then we press OK. And look what it gives us. It gives us this value of 3.84146. So there's our critical value, 3.84. Now, if you know that in biology, you're doing 0.05 is 1 degree of freedom. If you remember 3.84, you don't have to use your calculator to find it. It's not a requirement, but it's quite nice to know you can find it on a calculator. I'd say it's easier to remember 3.84 than it is to go through all those steps. Okay, so on the calculator now, we're going to take a look and we're going to find the chi-squared test. So rather than doing this calculation, this whole calculation, and working through this whole table, we're going to do a chi-square test more quickly. The way that we're going to do that is our next step. We're going to click on the menu button. We get a drop down. This time, okay, we're going to take a look at a matrix. We're going to make that table effectively as a matrix. So we're going to click 7, matrix and vector. Once we click 7, matrix and vector, we're going to create a matrix, so we're going to click on 1 to create, and as I said, a matrix, so 1, 1. Nice and simple. It already starts off at 2 rows and 2 columns. If we have a look, what do we have? We have the 2 rows and 2 columns, ignoring the totals, by the way. You don't put in the totals. So 2 rows and 2 columns. So if that was different, if it was 3 rows, we'd put 3 in there. If it's 4 rows, 4 in there. But it's 2 and 2, so we click OK. And that gives us our matrix to fill in. So much simpler this time. We're going to input our observed values. The calculator in the background is going to calculate our expected values and so on. We're just going to put in our observed values. So our observed values are 17 moving across, 21 moving down and across, 15, and moving across 7. So just to clarify, our observed values from our collected data, 17, present, present, 21, present, absent, 15, absent, present, and 7, absent, absent. Now we need to store that piece of information next, so the next thing we're going to do to store it, and we can see our store button here on our calculator, so we need control and store. So we're going to press control on our calculator and store. Oops. Sorry, I did it inside the brackets there, you would have seen. I'm going to pop outside of my matrix and try again. Control, store. Now I'm going to name it, today I'm going to name that bio. Okay, so at the bottom of your calculator you can name it what you want. Yes, you could name it eco for ecology, whatever you want, whatever you're doing at that time, as long as you remember it. In fact, I will call it eco for ecology. Excellent, and then we can press enter on our keypad and we've got that stored in there so we can use it. Now the next bit is to do the statistical test. So just like we've been doing each time, we're still in our calculator, we're going to press menu. This time we're going to be looking at statistics, so it makes sense that we're going to press 6. So we press 6. We're going to be looking at a statistical test. And this is quite easy to remember when it comes to statistical test because we're going to press 7. And then really, really nice, this is a chi-square two-way test for independence. Okay, two-way meaning there's a table with two sets, it's not three-dimensional or single linear. So we're going to press 8. So that was menu 6, 7, 8 to get through quickly. And it asks us to look at what observed matrix. We click on the observed matrix and eco is there may be others. We click on eco and we click OK and it calculates it all for us. And we're done. We don't have to do any of this. You don't have to waste your time going through it. There are online calculators as well that do this, but this is nice because you can't use an online calculator in a test. Okay, so you can't use it in your examination at the end. It gives us this value of 3.07, our chi-squared value of 3.07. It also gives us our probability value, which is 0.07 or 0.08, okay, which is greater than 0.05, which is what we don't want. We want that under 0.05. So, what we have here, we're just going to use our chi-squared value rather than confusing it. We'll notice it's slightly different from this 3.15 one that we calculated. Why? Well, it's slightly different because here we rounded everything to 2 decimal places, so we were rounding, so it is going to be slightly different. So that shows how error can accumulate. But the important information is this 3.07 or 3.08 if we were rounding there to the second decimal place, or to 3 significant figures in that case. It is still less than our critical value of 3.84. It's no bigger. So as it's no bigger, we accept our null hypothesis, species A is independent of species B. It's accepted. And that's the quicker way of doing it. Everybody happy with that? Good.